Let's take a look now at the idea of determining convergence or divergence. And what I'm going to do for each of these is simply take a look at the idea of a limit. Now that we understand some properties of taking limits of sequences, we can apply that to determine convergence and divergence. Now, one of the things you may be asking yourself is, why would you really care? Well, as recall, earlier I basically quickly defined the idea of an infinite series as a summation of an infinite sequence. So one of the very important aspects of infinite series is determining whether they converge or diverge. And we will connect the idea of a sequence, an infinite sequence, with that of a series. And it will actually later show that if the sequence diverges, then the series must diverge also. And if the sequence converges, then it's a possibility that the series will converge. So this idea of determining whether or not a sequence converges is actually extremely important when working with series. So what I'm going to do is take a look at this limit here. I want the limit as n goes to infinity of 1 plus negative 1 to the n, which equals 1 plus the limit as n goes to infinity of negative 1 to the n. This is clearly divergent. This itself does not exist because it's going to be bouncing back and forth between positive 1, negative 1, positive 1, negative 1. Therefore, what I have is 1 plus something that doesn't exist, which does not exist. Therefore, an is divergent. And again, just as a reminder, divergent does not mean it goes to infinity. We very commonly, with continuous functions, think of as a divergence as going to infinity or plus or minus infinity, but that's not always the case. In this particular situation, we're not going to plus or minus infinity. We're just bouncing back and forth this component between positive and negative 1, so it never settles down. Here, if I take a look at the limit as n goes to infinity of 3 minus 1 over 2 to the n. I did this in an earlier example. This equals 3 minus the limit as n goes to infinity of 1 over 2 to the n. This goes to 0, so this is actually equal to 3 minus 0, which is 3, therefore convergent. Now, I did this earlier. I'm just repeating it because now we've actually much more formalized the idea of what a limit of a sequence actually is. And actually, this next example I believe I also did earlier. Take a look at the limit as n goes to infinity of n over negative 3n plus 1. Now, this goes to infinity over infinity, well, infinity over negative infinity. So I can use L'Hopital's rule. So this converges to a negative 1/3, so therefore an converges. Or we can say that an is convergent. Now I just used L'Hopital's rule on here, so let's go ahead and work with this and kind of formalize this a little bit more. We can use L'Hopital. I've been using it. We can use L'Hopital's rule to help us with these limits. Here's another example using L'Hopital's rule. Just as this previous one, here this actually would have gone to infinity over negative infinity, which is a negative infinity over infinity, which is not equal to negative 1. Don't be canceling out infinities. That's not a good idea. Here's another example where, again, I can apply L'Hopital's rule. See, as n goes to infinity, ln of n squared goes to infinity, as does n go to infinity. So this thing goes to infinity over infinity, which is an indeterminate form. So I can say, based on L'Hopital's rule, that this is equal to the limit as n goes to infinity of 1 over n squared times the derivative of n squared, which is, that's a square right there, which is 2n, divided by the derivative of this, which is 1. Well, this n will cancel here, so what I end up with is the limit as n goes to infinity of 2 over n. That will go to 0. Therefore, an, there we go, an converges to 0. What that's actually telling us, if we think about this, is that obviously ln of n squared goes to infinity, and n goes to infinity. But the mere fact that it converges to 0, what that's really telling us is that n goes to infinity faster than ln of n squared. Hence the reason we end up converging to 0.